Hello! In this presentation I am going to cover SQL Server stored procedures. First, we'll define a stored procedure. I'll give example of a very basic stored procedure. I'll cover input parameters, output parameters, variables, and then we will go over control of flow statements in SQL Server. I'll look at cursors, and finally handling exceptions. A stored procedure is defined as SQL code that can be saved and reused. Stored procedures are essentially database programs, and they can have elements such as select, from, where, loops, and variables. Stored procedures are stored in the data dictionary and are used, among other things, for data validation and access control. Stored procedures are used as the basis for reports, e-commerce transactions, data analysis, and data cleansing, among other things. A stored procedure provides an important layer of security between the user interface and the database. A stored procedure can preserve data integrity because we can force data to be entered in a more consistent manner. Also, a stored procedure can improve productivity because statements in a stored procedure only must be written once and they can be reused over and over. Stored procedure offer advantages over embedding queries into, say, a web form or a graphical user interface. Stored procedures are excellent at reducing network traffic. We only have to send over an execute stored procedure name across the network, and then the stored procedure can execute server side and then transmit just the answer. This means that only the call to the stored procedure is sent over the network. This is our first basic stored procedure. This is how to create it. First, we say create procedure, and then we give it a name. I always put USP at the start of my stored procedure names. The system has dozens, if not hundreds, of system stored procedures, and they start with SP. So when I put USP, it stands for Users Stored Procedure, and I can find my own very quickly. This part of the stored procedure, from the select through the order by, is a normal query that we've seen all the time. We're looking at the ticker symbol, and for each ticker symbol, the total volume of shares traded. This piece of code needs to be run separately. I need to run the code from create through order by that creates a stored procedure. Separately, I execute this stored procedure by name. I can put exec or execute. Now, sometimes I've had students take the entire block and run it once, and that puts the exec statement at the end of the stored procedure, and it keeps calling itself, and it'll do that 32 times and then it will stop. So we don't want to do that, and that's our first basic stored procedure. Here is the stored procedure in SQL Server. So I'll go right ahead and I'll execute this top portion. It runs, it gives me a successful completion. I will now execute it, and now I should get a list of my ticker symbol and my volumes. Here at the bottom I see ticker symbol and the total volume. Now let's look at where we would go to maybe modify that stored procedure. So if I right click here on stored procedures, refresh, there's my total volume, and I could go and I could modify it. Here is a stored procedure with a single input parameter. I like to put a drop procedure at the beginning of my stored procedures so that if I run it and rerun it and rerun it until I get it exactly right, I don't have to go keep finding where it is and dropping that stored procedure. I create this procedure and I'm calling it USP current age. The single input parameter it takes is a variable called date of birth, and it has to be in the format of date time. it is going to do a date diff in terms of years between the date of birth that the user will input and get date, which is today's date. We will run this part to build the stored procedure, and then we will run this part to execute it. Here is our stored procedure in SQL Server. Let's build the stored procedure, and then we will put birth dates in it to make those calculations. We click execute, and it's built. We will use February 2nd or February 20th, 1995. That would be 25 years of age. And let's just change for a moment to say 1992. And we will use June. And let's do 08. If I run it with that one, it will show 28. Now, what if I wanted to see the difference here in days? How many days old is this person? Let's rerun our stored procedure to build it. Let's execute it with that June 8th. And we have 10,223 days. We have a lot of flexibility in the days that we can input in this stored procedure, and we can rebuild it to see different differences in time. Here is a stored procedure with two input parameters. First, if the procedure exists, let's drop it. Then we create the procedure calling it Van Halen 11, and here are the two inputs. At ticker is our first variable. It'll be a char. At tDate, that's going to be of date time. That's the second thing here that we declare. Select star from stock data where ticker symbol equals the first variable and trade date equal the second variable. Once we run that and create the stored procedures, then we execute the stored procedure. Here's our first parameter that we're passing, and here is our second parameter that we're passing. Here is that procedure then in SQL Server. Let's highlight the entire portion except exec. We will execute it, and we will see then that we've created the stored procedure called Van Halen 11. Let's run the stored procedure passing the parameters of Apple and April 1st, 2020. And we will note that that's the answer that we got here, Apple for that day, so that's going to return one row. This next stored procedure is quite a bit more complicated. We are going to show an output parameter, a variable, and control flow in a stored procedure. So we drop the stored procedure if it exists, create it, and we have two parameters. We have one is an input parameter, and that's going to be at trade year type small int, and at days traded will be an integer, but it will be an output. Here's our control flow beginning with begin and goes to end, and we are going to get ticker symbol trade date closing price from stock data, where year of trade date is equal to the variable that will be passed to the stored procedure. Now this part is something we might not have seen, and we select at days traded equal to at row count. At row count is a variable that's made by the system, so it will count the number of rows in our output and stuffs it into the variable at days traded. Then we declare at count to be of type int. When we execute the stored procedure, we will here say that at trade year is equal to 2018, and at days traded equal to this at count output. So we've stuffed into the at days traded the at count output. and we then select at count as total number of trading days. So here is that stored procedure in SQL Server. Let's go ahead and run it, and we run it to the end statement here. And so we built the stored procedure USP number of trade days. Now we'll run this section. So here we declare at count to be of type int, and in fact at count down here is what is going to be output. It's going to be calculated using this at days traded equal to at row count, and then at days traded will be used to output the number of trading days. So let's run that. Let's go look at our answer, and notice it says number of trading days 25,097. Well, somebody might ask, how are there 25,097 trading days in 2018? But remember, that's for more than 100 stocks, and there's not a trading day on every day. Clearly, holidays and Saturday and Sunday, we don't have trading days. So that's a little bit more of an involved stored procedure. This next stored procedure is pretty long, and it's actually 3 stored procedures, and at the end we combine those 3 into one. So the reason we do that is because we're creating a table, and then we are going to populate it. And you can't do a stored procedure that in one step builds it and then figures the data and inserts it, because that structure has to exist beforehand. So here's the first stored procedure. It's called USP create calendar, and we're creating a calendar table for utility, and it has an actual date, a month name, a day number, a year number, a day of the week, and a day type. Now the day of the week is either Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, or Saturday, and the day types are business, weekend, and holiday. The second stored procedure, we will call it the same thing virtually, but we will add a digit 1. So the second one's called USP create calendar 1. And in this one, we will do some looping and some inserting. So we declare an at counter, we declare actual date as date time, we declare at first date should be of type date time. And this calendar is going to have dates from January 1st, 1900 to December 31st, 2050. So we will set actual date equal to the first date, and that, of course, that was January 1st, 1900. And then our counter will be where it's less than 55,153. That's how many days in that time span. And then we do an insert. So we insert inside of a loop here in the stored procedure. In our next section, we are going to put days of week, day number, month name, year number, day of week, day type, whether it's weekend or holiday or business. So that's our third stored procedure called USP create calendar 2. So we run each of that section of code to create those 3 procedures. Finally, we do the fourth one, and it's called USP create calendar 3, and then it's create that procedure, execute the first one, execute the second one, execute the third one, and it runs. Now remember, there's one step to build a stored procedure and another one to execute it. So let's build each of those first 3 stored procedures and then the fourth one and run it. So let's highlight this drop procedure, drop table, and we'll do this first part through calendar, and I will execute. Okay, so that first stored procedure is created. Now let's go through and do the second one, and that's our loops and our insertions. So let's go to there. Okay, let's do our third one. Those first 2 were successful. It's our create calendar 2, and we will set our days of week, month name, year number, day type, and so forth. And I'll get my holidays, and I'll run that. Okay, finally, let's do the last one. And that is going to be executing stored procedure 1, stored procedure 2, stored procedure 3. And that is this create calendar 3. I'll execute it. And now I will execute this final procedure. And it is creating the calendar table. And while it does that, I'll scroll up here. It takes a minute because it is creating all 55,000 plus days, and then it one by one is going to put a day number, a year number, a day of the week, and it sets that up. So here we see the rows that were affected, and why don't we just do a select star from calendar to show what it looks like. So we will say select star from calendar run that, and now we see all of those days. If we look down here at the results, actual date, month name, day number, year number, day of week type. So that's a stored procedure that created and populated a table. We had to get creative just a little bit to do that. The next approach I want to cover is a database cursor. And when I say cursor, it's not this kind of cursing that I mean. No, it's a database cursor. And a cursor is an object that enables us to go row by row in a result set. People don't often teach cursors in databases because they're harken back to an old school era of line-by-line programming in COBOL. Relational databases are inherently set-based, and so doing this in a row-by-row is considered suboptimal. However, there are specific situations where that is the only choice. So we work at an individual row-by-row process, and it's a last resort. Here is an example then of a database cursor. We will create the stored procedure and call it my cursor. We declare two variables, @ticker symbol and @close, and their data types. We also declare a cursor, and it is called cursor ticker. We'll do a select statement, ticker symbol, close, from stock data, where year of trade date equals 2019. So that's our little select statement. Now we open our cursor, and we will fetch next from our cursor into these two variables, @ticker symbol and @the closing price. And we will continue to fetch until there isn't anything left to get. So we say while at fetch status equals 0, we will continue to do that until there's nothing left to get. Here we begin and we print @ticker symbol, the variable, plus, and we will cast the @close as a bar chart so we can put those together. And we will fetch next from the cursor ticker into @ticker symbol and close. We will continue to do that until there's nothing left to get. When there's nothing left to get, we will close the cursor and we have to deallocate it. Here is our stored procedure that we will execute and run. Again, this is our cursors. So I highlight it. We see the cursor that we've declared, we've opened it, we're fetching, we're printing it to the screen, we close, and we deallocate here. Now this isn't an example of the most useful cursor, but it is a cursor inside of a stored procedure and the way that it is used. So let's execute, and we see that it's successful, and now let's run it. And we're getting all the rows here for 2019, and we see the ticker symbol and the closing price. So that's a little bit more of an advanced stored procedure using a cursor. Here is the final stored procedure, and I wanted to show it because it's a lot more complicated, and it is a stored procedure used to insert JSON. So once we get this stored procedure done, someone can pass us stock data in a JSON format, and we can insert it into the table. So we've got the drop procedure, the create procedure, and here is the stored procedure that lets us do that. It trims off several spaces and a little bit of the ugliness and lets us insert it. Here then is an exec statement, and we see that we execute the name of the stored procedure, and here to here is the JSON. So that's JSON that will be inserted, parsed, and then put into our table. In conclusion, stored procedures are incredibly powerful. They're useful, and in industry, people write code all day long inside of a stored procedure.